Math 252, section 7.1, the definition of the Laplace transform. This is video 2. We're going to do some more examples. We're going to start with example 3a from the book. That's the Laplace transform for e to the minus 3t. By definition, the Laplace transform is this integral that's written right up here. And so we'll just apply that. This is going to be equal to the integral from 0 to infinity e to the minus st times e to the minus 3t dt. We could add the exponents because we have the same base there. So that's the integral from 0 to infinity e to the minus s plus 3 t dt. And now we can just go ahead and integrate it. Remember, for the purpose of the integration, we're thinking of s as a constant. The variable of integration is the t. So we're thinking of s as a constant for now. And then when we're done with the integration, we'll have s in the answer. And so we'll have our answer written as a function of s. So let's do this. It's just going to be e to the minus s plus 3 times t divided by minus s plus 3. That's the integral. You could do the substitution w equals minus s plus 3 times t, thinking of s plus 3 as a constant. Anyhow, that's going from 0 to infinity. And as long as s is big enough, this limit as t goes to infinity, this will be 0 as long as s plus 3 is positive. As long as minus s plus 3 is negative, you got a negative number times t in the exponent, that's going to go to 0. And so you're just going to get the minus of what we get when we sub in x equal t equals 0. So that's going to be e to the 0 over s plus 3, or just 1 over s plus 3. And again, what do we need for that? We need s plus 3 to be positive, so that we got e to a negative number times t. That is to say, s has to be greater than negative 3. So that's the Laplace transform for e to the minus 3t. And in general, I'll tell you this now, the Laplace transform, you could just do this. You could replace the minus 3 with a k of e to the kt. Is just going to be 1 over s minus k. All right. Let's do example 4. This is example 4 from the text in this section. We're going to evaluate the Laplace transform of sine of 2t. And again, by definition, that's equal to the integral from 0 to infinity e to the minus st times sine of 2t dt. And once again, we're going to do integration by parts. This is, you might remember from your Calc 2 class, that for this one, we're going to have to do integration by parts twice and then solve for it algebraically. I think it's maybe slightly easier to differentiate e to the minus st, or maybe slightly easier to integrate. Not sure. It might be slightly easier to integrate sine than to differentiate, than to integrate e to the minus st. So we'll set it up that u equals e to the minus st. du will just be minus s times e to the minus st dt. dv will be sine of 2t, sine of 2t dt, and v will be minus cosine 2t over 2. And so now this whole thing, I'll just write L, is equal to uv, so that's going to be minus e to the minus st times cosine 2t over 2. That's going from 0 to infinity, minus the integral of v du. We got a 1 minus sign here, a second minus sign here, and the integration by parts formula will give us a third minus sign. So this whole thing is still going to be minus. So minus the integral from 0 to infinity of, we can pull the s over 2 outside because we're integrating with respect to t. We're thinking of the s and the 2 as being constant multiples. And then we have e to the minus st cosine 2t dt. And now, as t goes to infinity, this is going to go to the first term goes to 0, because e to the minus st, as long as s is positive, e to the minus st will go to 0, and cosine of 2t is bounded. And so we're just going to plug in t equals 0 and subtract. So since we're subtracting, we're going to lose that minus sign, and we're going to get e to the minus s times 0, which of course is going to be 1, cosine of 2 times 0, which of course is 1 again, over 2. So that first term is just going to be 1/2. Minus, well, we're going to do integration by parts again here, but I didn't leave myself enough room, so I'll just copy that over and do it in the next step. And the integration by parts, we're going to follow suit. If our new u was our old v, then we would undo what we had did in the last step, and we'd end up with the Laplace transform is equal to itself, which wouldn't do us any good. So u is equal to e to the minus st du is minus s e to the minus st dt. dv is cos of 2t dt, and v is sine of 2t over 2. And so this whole thing is 1/2 minus s over 2 times the quantity. We got uv, so that's going to be sine of 2t over 2 e to the minus st. This is going from 0 to infinity. Minus, we're just doing integration by parts. We got the minus s over 2 on the outside. We factor that out. So now we're just writing out the integration by parts formula. So it's going to be the integral from 0 to infinity minus s over 2, so that we can write that as plus s over 2 sine 2t e to the minus st dt. And this integral is our Laplace transform again. The one with this integral is exactly what we're searching for. So we're going to solve for it algebraically now. First of all, let's evaluate 1/2. Let's distribute the minus s over 2. As t goes to infinity, that's going to go to 0. And as t goes to 0, sine of 0 is 0 as well. So that's just going to be 0. That first term goes to 0. And so we don't need those square brackets after all. And we have minus s2 times an s over 2. And then this whole thing is just a Laplace transform again. So we add that s squared over 4l to both sides, and you get l plus s squared over 4l is equal to 1/2. And then factor out the l and divide both sides. So l, and this is l of sine of 2t is what it was, correct? Yes, sine of 2t. Is equal to 1/2 over 1 plus s squared over 4, which we can write as 1 over 2 plus 2s squared. Something's wrong. Oh, that should be, yeah, it's just at the very end. Let's just multiply top and bottom by 4 in order to clear the denominator. And we can write that as 2 over 4 plus s squared. That's more like it. All right, so this video is about long as it needs to be. So in the next video, we'll give you some properties of the Laplace transform and list some of the basic ones, some of the similar to the ones that we just figured out just now in the last 2 videos.